Okay, so how many people are familiar with what Google Protobuffers is? Other than Patrick. Okay, well, basically it's a library that Google wrote, a guy named Kenton Varda, and it's a library for creating serialized message classes that can be then written and read from a variety of different streams or from disk. It handles versioning of the message format automatically, which is one really nice thing about it, so you don't have to worry a lot about ABI breakage and that kind of thing. It also allows you to have a simplified message format that you define in these .proto files, and we'll get to that in a little bit. And then it outputs generated code. And the nice thing is it generates output code in C++, which we use in the Drizzle project, or Java or Python. And there's just a crapload of other languages that people have supported, just not officially through Google. Google only supports the Java, C++, and Python, but there's Tcl, Erlang, C#, a whole host of languages. And at the end, I'm going to cut out of the slides and actually show you the code that it generates, and then where we're trying to use it in Drizzle to get rid of what we call the .frm file, the format file. And the generated classes that the Proto-C compiler produces represent a single message that's going to be passed to and from either through an input-output layer or written to disk as some serialized format. So the .proto file is what you use to define what a message is. What is a unit of message that's being passed between objects in the system. Very simple syntax, which I'm going to show you in a second. The fields in the message must be identified via a numeric index, and this is kind of important. The index starts at 1 and then goes up. And there's a certain optimization for the first 16 fields that has to do with how the compiler actually works. It uses a fixed 2 bytes that represent the first 16 fields doing bit mapping. But you'll see in a second. And then messages in the proto files can import and subclass other messages, which is really nice for encapsulating a part of a message as another class. So let's see what it kind of looks like. So here's the table.proto, which I'm just going to use the libdrizzle, or the drizzle as an example. But as you can see, we've got an import statement where we can import other proto message definitions that we're going to use in our class. And then we can also kind of give it a package. And the package, depending on the generated class programming language, means different things. In C++, for instance, it means it generates actual namespaces, and Java as well. For Python, it's like a package thing. So it just depends on the language that it's being generated. And then you've got a braced encapsulation of what defines the message. And here, the table is a message. So if we want to pass information about a table in Drizzle, right, or a foreign key constraint or a field, right, we have to contain it inside a class. And what we name it is table. We could name it anything, but it's stuff about a table. Import command. Import's another proto file. One thing to be aware of is you can have the files in a different directory, but it's kind of a pain in the ass to compile them that way. I just prefer to just dump all my protos in a single file. It makes scripting stuff in the make file and stuff like that a lot easier. And it's nice because it allows you to separate the message classes into different files. It allows you a little easier maintenance. You could put all your messages in one giant proto file and just use one giant proto file, but I think it's actually easier to create different files for each message. The package, like I said, it produces namespaces in C++ and Java, but for Python, it just basically makes an import dot in package management. So depending on the language, this kind of does different things, but it's a way to, kind of have namespaces or packages within your proto definitions. So this is actually what gets produced in C++. This is the actual code that gets generated. As you can see, we namespace drizzle, then namespace serialize. So if I have a dot, that's what's going to happen. It's going to have an additional namespace. In Java, it's the same thing. And then the class that is going to be generated is table, because that's what we called our message class, and it's going to inherit from the message class. So that I'm just showing you that to show you that when you put a message class in your proto file, it's actually going to inherit from the base message class, and so all the functionality that comes with that, we'll see in a second, goes along with it. So the ability to be serialized and deserialized automatically, and version independent stuff. So let's get a little deeper into the proto. So how do we define the message? We can have enumerations of different options. We can also subclass messages. So this is a really neat ability. So here I'm making a class that's within a class called table option. And since it's inside the table definition, it only will exist inside the table class. Okay, so you can't use a table option outside of the table class. And then there's members, field members or fields that compose the actual definition of the message. You'll have a descriptor for the field, the type of the data that it contains, the name of the actual field, in this case the name is name, and then a numeric index. The numeric index is required and it starts at 1. In an enumeration it starts at 0, just something to be aware of. Let's take a look and see if I want to cover anything else here. Okay, close the message class. Follow the term message with the name of the class, and that will become its actual C++ name, or Java, or whatever. And you can encapsulate them, which is a very powerful ability. Enum command, very similar to the way you express something in C++, only remember you have to have the semicolon after each. Just remember this, semicolon instead of comma. The syntax error that gets generated isn't very good. And if you're used to using commas and stuff, this can be a little tricky to wrap your head around, especially if you're a C person. Yeah, just remember to use semicolons as line endings there. We'll produce actual C++ enumerations in the code. We'll see a little example of that. If you leave out the index, it will be 0-based. So unlike the field index in the message, you can leave off the index in an enum. But just like C++, you can skip sequences in the enum by specifying an index yourself. So I could say 0, 10, 11, to skip sequences, if I wanted to provide some space for other options. And this simply defines an enumeration. One really common problem is that people will define an enum and think that that automatically creates a field within the message class called table type. It doesn't. As you can see here, I'm defining the enum, and then I have to say I want a field of that enum type, and I'm going to name it type. So this is a common mistake that people make, is they say, okay, I put an enum here, and they just think that that's going to create a field called table type. It doesn't. You actually have to create a field with the type of the enum that you've created. Fields. Members of the message class convention, like I said, is descriptor, type of the field, name equals index, and then I should have put semicolon at the end. Remember, the index is 1-based. And the indexes 1 through 16 are better performing because they don't use a length encoded lookup into an array. The first 16 fields are a statically sized array. So very, very fast lookups on those. So put your most frequently accessed fields in 1 through 16. Everything else, chuck it over 17. So the descriptor describes the field, obviously. There's three different things. Required means that before the message class can be serialized to anything, either a stream or to disk, that field must be non-null. It must be set in the instance that you create. So if I create a table instance, I have to set name before I can actually write it to a stream. Okay, so it's just a little bit of safety in there. Optional is the default. It means that the field is nullable, essentially. And then repeated means that the field is a collection. It's a dynamic array of a certain type. So you can have a repeated strings, repeated numbers, repeated other message classes to do encapsulation in that way. Type, expected type of the field. There's a whole host of integer types. Then there's string. You can also have an enum, which you've defined as a type. Then you can also have other message classes as the type. So let's see an example of how this all works out. I'm just returning here. So yeah, here's the descriptors, the types, the name of the field, then the index. So here, what I'm showing, here is a field of storage engine message class. So notice that in the beginning I imported the storage engine proto file. And I have the package set as drizzled serialize. Well, here, in order to say that part of the table message class is an engine, and that engine field is of type another message class called serialize.storageEngine. And this is a way of encapsulating classes within each other. Here's an example of the repeated descriptor. So, a table message is composed of one or more fields, right? And so I have a message class field. I have a repeated descriptor of the field. So I have a dynamic array of fields that I call field, and then give it an index of 5. There's some dispute as to whether I should call this field or fields, since it's repeated. There's a reason I make it singular. And I actually, when I first started working with Google Protobuffers, I made it plural. So it would be fields and indexes. The problem with that is when you actually access the data, you actually have to call fields underscore size to get, so you're saying access at fields, and it just becomes like, it grammatically incorrect when you actually use the class that's generated. So I recommend using the singular form because I had to undo a whole bunch of code because I'm like, I hate stuff that's not grammatically correct, and I was constantly going fields size at fields, and then I was just like, that doesn't work. And then at the bottom you can see an example of the optional. So there's an optional comment for a table. And so remember that this actually represents something inside the drizzle. Right? It's a table inside drizzle. And this is how we're going to, all the information about the table that can be stored. And so when we write to disk or write out to, for instance, the replication log or something, we can put all the information about a table and pack it really tightly into this Google Protobuffer message format, and then send it across the wire. And on the other side, we can read in from the wire, and it'll just create the message from the wire. So it's a really easy way of sending messages across either a network or stored in serialized form. How do we generate the classes? So we've got these proto files sitting in a directory. We then use the proto-C, which is the compiler for Protobuffers. We pass it a couple little options, just say cpp out, C++. It's saying generate C++ classes in this current directory. And then pass it the name of the file, the proto file. And what this does is it generates two things in C++. It generates a .pb.h, so a table.pb.h, and then table.pb.cc file, so the header and the implementation files. Then in our code, where we want to use these generated classes, all we have to do is simply include the generated file. Don't change the generated file. Done this. Also, don't do this. Do not inherit from the generated stuff. Basically, if anything's generated, just don't touch it. Don't inherit from it in your code, because as soon as you change something, you're just going to break all the code that you just wrote. Instead, encapsulate something. And by encapsulating it, I mean you can have, for instance, table definition object, and within the table definition object, I can have a pointer to a table class. Okay, which represents the message. So don't inherit from what's being generated by Proto-C. That's a big thing. And that's about it. But then I wanted to just kind of show an example of the usage of this. So just give me 1 second to open this up. Can you all see this? Too small? Come on. Okay, so here's an example of this table definition class. Remember, we don't want to inherit from something, we want to encapsulate it. So as you can see, I'm including the generated stuff. So Proto-C has already generated this table.pv.h, which has all the information about a table. So a table class that's represented as a message derived from the Google Protobuffers format. And here, you can see I've got a table, and I've encapsulated the generated message. And I've got an instance of it that I call message that's inside my table definition.
Is that really just for debugging, for consistency stuff, or do you use it to populate?
I'm sorry?
The message, is it really, you just use it for reference?
Well, no. So this class table definition is just a general class that I use to access all this stuff on the wire or wherever it's coming from. Now, table is the Google Protobuffer generated table message class, and that is actually what's going to get written to the wire. Table definition is just a wrapper so that I can access information about the message class and add stuff to it, and make some convenience functions and that kind of thing. So here's an example of that whole plural versus singular thing. So the message is what's been generated. It's the Google Protobuffer class. It's an instance of that. If I want to get the table option, a list of table options, I can use the message.option and give it an index, x. Here, as you can see, to get the number of options, I say message.option size. I was sick of saying options underscore size, because all these are generated functions. So it follows the standard API. So you know that your message class is going to have, the name of the function is the name of your field. And to access a repeated field, you pass in an index. And then you access the field in the same way. So a table option has a value field. To get the value of the value field, you would say option.value, parentheses, parentheses, and that returns whatever the type is that you've set that field to. In this case, it's a string. A very simple example of how we would read something that's been serialized in a binary format through the Google Protobuffers library. We use this little macro here that allows us to do all the version automatically stuff. Then what we're doing is we're creating a table by reading in parse from input stream. What we do is pass it the input stream that we've created from the file that we passed in the program. Table, because it inherits from the base Protobuffers message class, has a method already, parse from iStream. Has a lot of other methods, parse from zero copy stream and all sorts of different stuff. And what this does means is when you've defined your proto file, you've created this message which inherits from the Google Protobuffers message, and therefore inherits all these nice little methods that allow you to read and write from all different types of streams and not have to worry about any of that. I know I'm doing a really bad job of explaining this kind of stuff. But that's the basis of Google Protobuffers. It just allows you to do reading and writing of serialized messages in a highly, highly compressed format. That's about it. So, any questions? I know this is a really bad presentation because I wrote it 15 minutes ago. But is there questions I can answer? Yeah.
I have a loaded question, but use XML.
Okay, so
this is about 400 billion times quicker.
Right, and actually the number
Upgrade the whole upgrade path.
the first thing on the Google Protobuffers homepage is why don't we use XML? And they did a whole bunch of tests, and the compression ratio and having to basically parse and unparse the stuff was so expensive that they just said there's no way that this is going to work. And so that's the reason. And Google Protobuffers is what they use internally at Google to pass messages between all their systems. And it's language independent, which is a big thing. I mean, if we're going to be creating plugins in Java and C# and C++ and Python, we have a common message passing format that produces a binary stream that any language can read in and create objects. And that's very important that we have that ability to do that in a highly compressed and performant manner. So that's why. It was because of performance in space.
I was assuming so, but
Yeah.
So, wasn't Corba kind of like, no, I guess not Corba, was kind of like the attempt to have sort of a generic, like,
Common object request broker.
right, I guess that
whatever.
ran stuff in other objects and they would run in like whatever language it was or something?
I don't know. I don't know if Python ever implemented a Corba interface. I know
Right.
Java and C++ did, but I don't know. And they also investigated Corba, and they've got their own reasons for not liking it. I think because it was a proprietary technology was the number one reason, or they didn't want to be tied to something. But the main one was they didn't like XML. But I know that they investigated Corba. I just can't remember the exact reasons why they said no. Yeah.
You would have attempted to take the Java protocol and convert it to a bunch of these messages, so for extremely low bandwidth situations or something like that, that could be useful.
Well, the thing about Google Protobuffers is that it's not actually implementing a protocol. It's actually implementing the message format. It's not actually telling you how you have to send those messages across a network. It's just providing a format that can be read and written to. So
Sure,
I mean,
so you take your actual formatted XML from the Java protocol and convert that, and over the pipes, you just send that, but any...
so you solve the
you
size
solve the
problem
connectivity.
on
Yeah,
either
exactly.
side. I see what you
You
mean.
get some
In that
gain
case,
there.
I'd just say just use tar, like tar and gzip. Just run it through. If it's just compression that you're looking for. But if you want, for instance, something that can be read by Python or Java or C++ or really anything, which might be a benefit for Jabber. I don't know. I don't know enough
Can you
about Jabber.
contrast this to what's I've heard of Thrift as
And I haven't, so I can't contrast.
Right. It's I guess I guess I didn't realize it's not an Apache project, and they seem to define data types and services interfaces in a definition file that runs across multiple clients.
Sounds very similar. Yeah. I mean, I'm just not sure. But yeah, there is a mailing list, and like I said, the guy that maintains most of this stuff, his name is Kenton Varda, a Google employee, and they're very active on the mailing list. So, all right, cool. Well, find me later if you have any questions or want to see some more in-depth stuff. Cool, thanks.
So if I'm searching for it, is it called Google Proto or Proto?
Google Protobuffers, or just type in Protobuffers into Google, and I think they'll probably find it.
Proto.
Okay.
Sorry.
It's okay.
Is it challenging maintaining these .proto files? Like, do do you expect people will come up with stuff
Sure.
like, I'm a Ruby developer, I'm used to Active Record, look at my database and I'll get back a whole bunch of .proto files all kind of configured. Like I think that was like.
Well, the proto file only lives on your local, because the proto file is only used to generate classes in other languages.
Okay.
So that's it. I mean, we just throw it into Bazaar like any other file, and all it is just a definition of a class that can be then read by the compiler and spit out in a bunch of different languages. So you wouldn't be passing proto files around.
Oh,
Is there a way to
generate that
proto files themselves from, say, your database schema? You provide a couple models, and
or from my Ruby
gives you a head start.
I am sure you could script that. And,
Right.
oh, yeah,
It's
Ruby or
somewhere,
Python.
right?
Need something to do for tomorrow, right?
Yeah, I'm sure there's a way. I mean, you've seen, I mean, the proto syntax is incredibly simple and very similar to actually, a table definition, really. So, like a SQL table.